Oh, geometry kids, here we go. We are on section 9.1 on translations. But before we specifically get to translations, let's talk about transformations. We've talked about this before in other classes, right? We talked about the transformers and how you got a guy and it turned into like a house or something. I mean, it was just this totally random change. So a transformation is a change in position, shape, or size of a figure. Okay, so it can be any of those. Change in the position of it, change in the shape, or a change in the size. So, when we are talking about all of these different figures, because we're going to be doing that throughout this chapter, we're going to get to reflections, and what's after reflections? Symmetry, and dilations, and rotations, tessellations, etc., etc. So, whenever we talk about these, we are always referencing the pre-image as your original figure, so the one that you start with, so like your starting place, and your image is your resulting figure after transformation. You know what, I gotta move this up a little bit. It's just too far down, and I don't like having to switch this all the time. Okay, there we go. So next we're going to talk about isometry. So an isometry, that's how you say that, isometry, is a type of transformation, but it's one that gives you a situation where your pre-image and your image are congruent. And you know what congruent means. They're exactly the same. So let's get that down. A transformation in which the pre-image and image are congruent. So a situation like a little tree, love drawing trees, and a big tree, that is a transformation, but it is not an isometry. They definitely look like they are similar figures, but they are not congruent figures. So therefore it is not an isometry. An isometry is a special one that is congruent. So when we look at this picture down here, does that look like an isometry? Yes. I hope you're saying yes. Then the question is, which one's the pre-image and which one's the image? Well, I'm guessing you may figure it out because you see the arrows, although I haven't told you many other clues yet. But the pre-image in this case is this one, and the image in this case is this one. And you might wonder how I knew that, other than the arrows. And it's this little thing here, the little prime, we call it. Prime. So J is my original, and J prime is my transformed point. K is my original point, K prime is my transformed point. Q is my original point, and Q prime is my transformed point. So oftentimes you'll see something like this where it says triangle JKQ, JKQ, lining and order matter, and then this arrow, and then the other triangle that it transforms to, J prime, K prime, Q prime. So that's a little prime, and it goes above it, it's like a little slash. You're going to be doing a lot of those. But what this means, this line right here, it's not triangle JKQ arrow triangle J prime, K prime, Q prime. We use the phrase maps onto. So triangle JKQ maps onto triangle J prime, K prime, Q prime. Okay? So now, before we move on, I want you to flip your books to page 545. And look, I got it number 2. I got my book here. I'll try to put it under here so that we can go through it. Let's see how this works. Not too bad. Okay, so we're looking right here at got it number 2. In the triangle, triangle NID maps onto triangle SUP. What are the images of angle I? Well, you're looking over here, and you might be able to figure it out by looking at the picture, but you can also figure it out by looking at the order that it's up here, and I think that's actually easier. So angle I would, the image of angle I would be angle U. And the image of point D would be point P. And then it says, what are the pairs of corresponding sides? So again, you can use this. NI, oh, there's the cuckoo clock. NI is congruent to SU. ID is congruent to UP. And then ND is congruent to SP. Okay, so those are all your corresponding sides. Okay, hang on, I gotta get this book out of here again. Okay, so we said angle I maps onto angle U, and point D maps onto point P, and I don't remember all the other sides, but we'll move on. So let's talk about what a translation is. You're familiar with a translation. You've worked with translations. It's also a transformation. Whoops. It's a transformation, and we also have called it a slide. I know we did this back in pre-algebra and algebra, I think. Algebra, I know for sure pre-algebra. And it is a, let's put the definition, we'll talk a little more. A transformation that maps all points of a figure the same distance in the same direction, also called a slide. Mapes? What the heck is that? Get the white out. Red alert. I want my white out. Where are you? There you are. I hope you noticed that. Do not report me to Mrs. Sullivan. I have corrected my error. Maps. Okay. So is a translation an isometry? And the answer is yes. Turn the page and we will take a look at one. What are the images? So I'm just making sure we're all clear here. What are the images of the vertices of triangle ABC for the translation here? So class, this is your rule, okay? This is like a rule. It tells you what to do with your X and your Y. So it's saying this is your pre-image, and if you put that through the rule, you're going to get your image. It's the similar thought of the function machine. So graph triangle ABC and its image use different colors. Okay, so we have ABC right here. I do not have the points listed. So go ahead and put your points on there while I take a nice drink of my Cola Zevia. Nothing better. Alright, so A, what coordinate is that? Negative 2, 2. And C, 1, negative, oops, I'm sorry, I'm going over there. 0, negative 1. and B is 1, 1. Okay, so we have A. I'm just going to list them vertically now. B and C. Whoa, don't like that. And our question is, what will they each, what do we use for this? Maps onto. What will they map onto? And we are going to call our new points A prime, B prime, and C prime. And I'm going to copy this rule down because this is XY. And it's going to map onto, I'm going to use a different color as directed, X plus 1 and Y minus 4. So A prime, B prime, and C prime. Okay, so now here's my X, here's my Y, and you put it in here. Okay, so our new point will be whatever X is plus 1. So negative 2 plus 1 is negative 1. Y minus 4. 2 minus 4 is negative 2. B, you go ahead and get B and C, B prime and C prime. Okay, this should be just about done. If you put in the 1 here, you get 1 plus 1 is 2. If you put the 1 in here, you get 1 minus 4 is negative 3. You put a 0 in there, you get 0 plus 1 is 1. And you put a negative 1 in there, and you get negative 5. So we have our new points. We use a different color now, and we're going to plot those points on here, like it said, graph this and its image. So this is the image. This was the pre-image. If you're hearing background talking, that's my husband. He's working in the other room. Okay, so we have negative 1, negative 2. So negative 1, negative 2. So I need to extend this down a bit, don't I? 1, 2, 3, 4, and 5. So negative 1, negative 2 is right here. And that is your A prime. Then we need the B, which is 2, 3. So 2, 3 is up here, and that is B prime. 2, negative, oh. Hope you were catching me on that. What in the heck am I doing? 2, negative 3. Let's try that. 2, 1, 2. Oh, almost right on that other point there. That's our B prime. I want to get rid of that point too. That's annoying. Get that out of there. I highly recommend this brand. This is Bic Whiteout. Easy correct. Makes for easy corrections. Alright, and then 1, negative 5. So 1, negative 5 is down here. And that is C prime, and that is 1, negative 5. Okay, so then you grab your straight edge, which I do have. And you connect them. Use those playing cards I gave you for your straight edge. Wow, that looks terrible. Let's just be honest about that. It must be, boy, I don't know what to say about that. That's just, I think it's the graph though. Look at how big that is from negative 1 to negative 2, and then these are only here. So I think it was my homemade graph there that threw that off. Alright, so that's my image, but as you can see, this is a translation. It's just slid down. It should look exactly the same if I were to use an actual graph. So hopefully yours worked out that way too. Let's take a look at the next one. A translation of triangle LMN is triangle L prime, M prime, N prime, with L being these coordinates. What is the rule that describes it? Oh, okay, so we're trying to get this now. So they're giving us this on the graph. We can get those, and they're also giving us the second part right here. So let's organize this. Okay, we will have our L, our M, and our N. And let's get those coordinates. So that looks like it's a -6, -1. And this one looks like it's -1, -1. And M is -4, -3. All right, and then we will, well, geez, we also have these. So we have our L prime, which is 1, -2, and we have our M prime, which is 3, -4, and we have our N prime, which is 6, -2, and you guys need to get this. So it's always going to be kind of set up like that, and they're saying, okay, what did they do to the X to get here? Look at the X, look at the X, look at the X, look at the X. Do you see a pattern? I'm hearing yes. Yes, Mrs. Silva, I see it. They are adding 7 here. 7 and 7. Very good. So they took the X and they added 7. Now, let's look at the Y. Here to here, here to here, here to here. What are they doing? That's right, they're going down 1. The Y, in this case, is going down 1. So here is, hey, where's my highlighter? Here is the answer. That's the rule. That's what it means to come up with the rule. Okay, so we're just about ready to wrap up here. It's a composition, we just have to talk about what a composition of transformations mean. And all that means is that there's a combination of 2 or more transformations. So this is one, right? It's a translation and translation. So a composition would be more than one. And it could be a combination of different ones, like a reflection and a translation, which was called a glide reflection. It could be two reflections, which then is a rotation. So you're going to learn all these different things here. But for today, it will suffice to say that it is a combination of 2 or more transformations. There we are. And the good news is I just want to let you all know that at the end of this chapter, I am going to do chapter 9, all the videos, and at the end of the chapter, at the end of the last lesson, I am going to offer a story time for all of your younger siblings. So you will be able to grab them around and have them come to listen to one of my favorite childhood books. So you have that to look forward to. I know you guys are excited. All right, talk to you later. Bye.